Hey guys, Jared here, and today we're going to check out 3 different CPU coolers from Noctua for AMD's TR4 Threadripper socket, and see how they perform both in terms of temperatures, but also overall system volume at both stock clock speeds and while overclocked. I originally bought the largest model available, the NH-U14S, for my 16-core 1950X CPU, but then I wondered if you could save a little money and get a smaller and cheaper cooler with perhaps similar performance. So I reached out to Noctua and asked if they'd be willing to provide their other 2 Threadripper coolers that also cover the full TR4 socket, the NH-U12S and NH-U9, and they were happy to help out, so huge thanks to them for that. Let's first discuss the main differences between these 3 coolers so we know what we're comparing. The first obvious factor is the size of the heatsink, where the U14S that I purchased first is the largest of the lot, followed by the U12S, and then the U9 being the smallest. As you can see here, the U14S actually covers the first PCIe slot of my Asus Zenith Extreme motherboard by default. However, it does have the ability to let you offset the heatsink by 3 or 6mm, and I didn't have any coverage issues with the smaller coolers. The U14S comes with a 140mm fan and weighs 1030 grams. The U12S comes with a 120mm fan and weighs 870 grams, while the U9 comes with 2 smaller 92mm fans and actually weighs slightly more at 895 grams owing to the extra fan. What makes all these coolers special is that they have full coverage of the Threadripper IHS, which should provide better cooling compared to other coolers that use the Asetek bracket. I'm going to be testing these 3 coolers with my AMD 16-core 1950X Threadripper CPU at idle and under full load, both with stock clock speeds and overclocked to 3.9 GHz. I simulated full system load using Ada64, and this was chosen as from my research it appears to be a more realistic workload when compared to something like Prime 95, and I was after something closer to real world than absolute insanity for this test. All tests were also completed with an ambient room temperature of 20 degrees Celsius, and I waited for over half an hour for the temperatures in each test to stabilize. First we'll discuss the idle temperatures. As expected, we can see that the larger U14S cooler performs the best at idle, both at stock speeds and overclocked. However, there's only a small difference of 1 to 2 degrees from one cooler to the next down the line. While running at stock speeds under full load, there's a little more difference. However, the results are still fairly close together. Only with a 3.9 GHz overclock across all 16 cores do we start to see a larger difference, with the U14S performing almost 8 degrees Celsius better than the U12S. While overclocked, the U9 was only a little worse off than the U12S, which I found interesting. Based on its size, I thought it would be worse off. It looks like the extra fan is helping it out. It is possible to add a second fan to the U14S and U12S. However, that wasn't tested here as I don't have additional fans, and I've tested with the fans that you'd get if you bought these coolers yourself. Cooling performance isn't the only concern. Let's next take a look at how loud the system got with each cooler. For this test, I'm measuring the overall system noise rather than just the CPU fans, and the case fans should ramp up and down based on the CPU temperatures automatically. So although this test depends on the fans of my case, hopefully it's a fairly real-world example of what you could expect to see. Or I guess here in this case. For reference, the case I'm testing in is the Thermaltake View 71. It's got quite a lot of openings for air between the tempered glass and the case. We can see at stock speeds the idle volumes are very close together, with a little more variance when overclocked at idle. Interestingly, I found that the larger coolers were slightly louder at idle, but quieter under full load. Overall, I'm pretty impressed with the system volumes. I've run much lower powered laptops that easily reach the 55 decibel mark, and 16 cores is quite a lot more to cool. Now it's important to call out that there are other Threadripper chips with less cores that probably run cooler than what I've got here. In this particular example, I've got the 16-core 1950X, which will likely produce more heat compared to the 12-core 1920X or 8-core 1900X CPUs. I don't currently have those lower tier Threadripper CPUs to compare against, so for now we'll just be getting an idea of the cooling differences with the top-end chip, which I actually think is better, as it should provide more of a worst-case scenario that these coolers would be dealing with. Based on these tests, it seems that running at stock speeds, any of the 3 Noctua coolers seem fine with the 1950X at both idle and full load. Only when overclocking is introduced do things start to get a little worse off for our smaller coolers. If you're planning on buying Threadripper and overclocking it, I'd definitely recommend the larger U14S cooler over the others if you have the room to physically fit it inside your case. I was originally planning on using the air cooler as a temporary solution, until there were more all-in-one cooler options available that cover the full Threadripper socket, but after my testing, I'm more than happy with the results of the Noctua coolers, and I'll be sticking with the U14S for some time to come. I'll have full benchmarks of the Threadripper system in a separate video, so make sure you subscribe for that if you're interested. Let me know down in the comments which cooling solution you'll be using for Threadripper. And leave a like on the video if you found the information useful. Thanks for watching, and don't forget to subscribe for future tech videos like this one.